Equation of kinetic energy. Let us now express the kinetic energy of an object in the form of an equation. Consider an object of mass m moving with a uniform velocity u. Let it now be displaced through a distance s when a constant force F acts on it in the direction of its displacement. We know that the work done W is Fs. The work done on the object will cause a change in its velocity. Let its velocity change from u to v. Let a be the acceleration produced. The relation connecting the initial velocity u and final velocity v of an object moving with a uniform acceleration a and the displacement s is v square minus u square equal to 2as. This gives s is equal to v square minus u square whole upon 2a. We know that F is equal to ma, so by using values of F and S in the equation of work, we get W is equal to ma into v square minus u square whole upon 2a. Or we can write it as W is equal to 1 upon 2 into m into v square minus u square. If the object is starting from its stationary position, this is u is equal to 0, then the work done, W is equal to 1 upon 2 into mv square. It is clear that the work done is equal to the change in the kinetic energy of an object. Thus, the kinetic energy possessed by an object of mass m and moving with a uniform velocity v is 1 upon 2 mv square.